In section 3-3, our first objective is to construct quadratic expressions and equations in context. We've done this throughout the course. This is just changing a verbal representation of a problem to an algebraic representation. So this shouldn't be new, and we'll continue to do this throughout the course. Now the real meat here is that we are going to learn to solve quadratic equations. Now I imagine much of this is a review from algebra, but we're going to run through quickly 4 different strategies: factoring, completing the square, using the quadratic formula, and also using our graphing calculator technology to solve equations. You might not have seen all 4 of these in algebra, but I'm sure you've seen 1 or 2 of these before. Alright, now quickly, when we think about quadratics, we have 3 cases here. Okay, so I have in blue this quadratic equation, x squared minus 6x plus 5. Alright, now if we look over here, the blue is our quadratic, and let's say we want to know when this equals -6. What do you see? If this is my equation, or my quadratic, the left hand side of my equation, this is the right hand side of my equation, do you see these two never intersect? They are never the same. So this would be the case where we have no solution. Or if you want to be very technical, some people might say no real solutions, but no solution for us. Alright, our second case here, here's my quadratic. Alright, here is the output value of -4, and these two equal once right here. Okay, this would have one solution. Okay, so just the tip of this quadratic comes down and touches that red line. Okay, and then our third case here, let's say we want to know when does this quadratic equation equal -3. Well, if that's the case, do you see these two are equal, or they intersect right here and right here. Okay, so this would be the case where we might have 2 solutions. Alright, so no matter which of these strategies you use, we could have any of these 3 cases. Alright, so what are the strategies we're going to use here? Alright, the first one we're going to use is we're going to solve quadratics by factoring. Okay, this one I think is the easiest, especially if you are good at factoring quadratics. However, it only works if our solutions are rational. So it's quick and easy when it works, but regretfully it does not always work. Okay, the second strategy we're going to look at is by completing the square. Alright, so this is a process by which we could solve quadratics, and it will work even when our solutions are irrational. Alright, our third strategy here is to memorize the quadratic formula. Alright, so when I'm considering the difference between strategy 2 and strategy 3, it's really whether you are a student who prefers to understand a process, would be strategy 2, versus memorize a result, quadratic formula, strategy 3. All right, and the last one is to use technology. All right, or the graphing calculator. Alright, so you could solve these similar to how we did in Unit 1. So we're going to try to run through all 4 of these in this video. Alright, so let's think about strategy 1, factoring. If the product of 2 numbers is 0, well then we know that one of the 2 numbers must be 0. Okay, so let's say if I had 5x equals 0. Well, 5 times a number equals 0. Well, we know then that this number right here must be 0, right? Okay, so similarly, if we have x times y equals 0, well, I know that one of these 2 numbers must be 0. Okay, so that is, if a times b equals 0, either a is 0 or b is 0. Okay, so here I have a quadratic which is already factored, and I have the product of 2 things going on here. So if I'm multiplying these 2 terms and I get a result of 0, one of those 2 is 0. So I might say either 2x plus 4 is 0, or it could be that x minus 3 is 0. Okay, now once I get to this term, this spot right here, to solve these you're just going to use a little bit of algebra here. So I subtract 4 from both sides and get 2x is negative 4. Then I divide both sides by 2, and we might get one solution is x equals negative 2. Okay, then over here I want to solve this one, so I add 3 to both sides and I get x is 3. Alright, so this was that case that we looked at a minute ago where I end up with 2 solutions. So this was this case on the far right here. I had 2 different solutions. Alright, so now let's see. If I have this quadratic over here and I want to solve it, well, the first step is it's not factored nicely like this one over here, so I might have to factor this. Okay, now we don't have time to review all of factoring here, but we'll do one example, and then if this doesn't jog your memory, I would encourage you to use one of the 3 other strategies. Alright, the first thing I'm going to do is look at this term here. Okay, 3x squared. Now, I need to break that into 2 factors. Well, if it's x squared, I'm probably going to have an x over here and an x over here. And then 3, well, that's nice because the only factors of 3 are 3 and 1. So I might have a 3x here and an x here. Alright, now I'm going to look at this term here, this 6. Okay, I need to break 6 into 2 factors such that my inside product plus my outside product give me this 11 here. Alright, now there are a number of ways I could do that. I could do 6 and 1, 1 and 6, 2 and 3, 3 and 2. So it might be a little guess and check here. It might take you a couple tries before you get the right one, or it could be the case that it doesn't factor, which is a drawback of this strategy. So I'm going to say if I want to get 11, I want the 3 on the outside, so that I get 3 times 3 would give me 9x, and then I want the 2 on the inside. So if I had 9x on the outside, 2x on the inside, that would add up to 11. Alright, so now that I have factored this, we can go back to the case where we just were, right? One of these 2 factors must be 0. So either 3x plus 2 is 0, or x plus 3 is 0. So I'm going to subtract 2 from both sides, so I get 3x equals negative 2, divide both sides by 3, So one solution would be negative 2/3. And then over here, if I subtract 3 from both sides, my other would be negative 3. So in this example, I don't have 0 on the right hand side like we did before. So what I might have to do first is subtract 12 from both sides so that I have an expression equals 0. Alright, now I can factor this. Alright, so I'm going to look at this first term. Well, x squared, that's easy. X and x. Alright, now I need two factors of negative 12 that would have a sum of negative 1. Well, I think that would be 4 and 3. Now it's negative 12. One of these needs to be negative. Now if I want my sum to be negative 1, I think I want the 4 to be negative. Let's see if that works. Inside I get negative 4. Outside I would get positive 3. Negative 4x plus positive 3x would give me negative x. Yep. Alright, so now I know that either x minus 4 is 0 or x plus 3 is 0. So this would give me positive 4, this would give me negative 3. Alright, now this one is looking a little more complicated. I need to get 0 on one side of the equation or the other. I'm going to subtract all of these terms to the right. So if I take 3x squared minus 2x squared, I end up with x squared. Okay, if I have 4x squared minus 2x, I end up with 2x. And then if I subtract 8 over, there is no constant term over here, this would give me negative 8. And I have gotten rid of everything on the right hand side, so now I have 0 there. Alright, so let's see if we can factor this one. An x and an x. Now I need two factors that would give me negative 8. So I think, but then have a sum of 2. So I'm going 4 and 2 here. Now which of those do I want to be negative? I want positive 2, so 4 needs to be my positive one and 2 would be my negative one. Let's see if that works. Inside I get positive 4x, outside I get negative 2x. I add those together and I get positive 2x. Yep. So then from here we know that either x plus 4 is 0 or x minus 2 is 0. So we get either negative 4 or positive 2. Alright, now I have said this a couple times before, but the problem with this is that all quadratic equations are not necessarily factorable. Okay, it only works if our solutions are rational. So if the solutions are irrational, then factoring won't work. So in other words, if you remember all the way back to the very first section, 1-1, all of these are rational solutions. I can represent them as a ratio or a proportion of two integers. If we had something like the square root of 3 as a solution, that would not be rational and we could not factor. Alright, so let's look here. We have a rectangular plot of land in which the length is 3 yards greater than the width. So let's call this one the width because it's shorter, and then this one is 3 more. Okay, we know that the area of this garden is 154 square yards. Alright, so inside here we have 154. square yards. We want to know what is the width of the shorter side. Okay, so to come up with an equation here, we need to multiply these two sides, length times width, or base times height. So I'm going to say W times W plus 3 equals 154. Alright, now if we're going to use our factoring strategy, we need to get everything over to one side and then expand everything out and see if we can factor this. So my first, I might distribute this W. So on my left hand side I would have W squared plus 3W. Alright, now if I subtract 154 over to the other side, I get minus 154 equals 0. Alright, now I need to factor this. Alright, now let's see here. I need factors of negative 154 that have a sum of 3. Well, I know that one's going to be positive and one's going to be negative if I have a negative product. Now this one is not jumping out at me, so I don't know if you remember doing these little factor trees, 154. Let's see here. If I break this up, what is divisible by 154? Well, it's even, so I know there's a 2 in there, right? So that would be 2 and 77 maybe? Okay, then 2 is prime. I can break this into 7 and 11 maybe? Alright, so here my prime factorization is 2 times 7 times 11. So let's see, if I group these two together, I would get 14 and 11. 14 and 11, I can see how those might give me that negative 3 I'm looking for. Alright, so which one do I want to be positive? I want positive 3, so I think that would be positive 14 over here and negative 11 over here. Alright, so negative 11 times positive 14 is going to give me this negative 154 I was looking for. Then inside I have positive 14, outside I have negative 11. When I add those together I get this positive 3. Alright, so it looks like we're on the right track here. So now either W plus 14 is 0 or W minus 11 is 0. So either W is negative 14 or W is 11. Now, algebraically, we have found two solutions. However, do you have some intuition that it would not make sense to say that the width of the shorter side is a negative value? So I'm going to throw this one away. Alright, so then my result here, the shorter side would be 11 yards. Alright, now we're going to change this slightly. Alright, we have here now, let's see, how did we change this? Let's come back here. Before, one side was 3 yards greater than the other, and the area was 154. I have changed this ever so slightly. We're still looking for W, the shorter side, but now this side is 4 yards greater, and we have an area of 101. Alright, so let's see if we can, so we'll start off the same way. W times W plus 4 equals 101. I am going to distribute that w as we just did, and then subtract 101 to the other side, and I get w squared plus 4w minus 101 equals 0. Alright, and as we did before, we want to attempt to factor this. Now here's where we get stuck. If I think about 101, I believe that is prime. I can't factor. It's not even. It's not divisible by 3. It's not divisible by any even number. It's not divisible by 5. Yeah, I think I'm stuck here. I can't think of any factors other than 1 and 101, which obviously would not give me this 4w I'm looking for. So this one is not factorable. Okay, so while strategy 1, factoring, is quick, and we didn't even need a calculator for most of these problems, it does not work if my results here would end up being irrational. Alright, so let's try another strategy. Alright, so recall strategy 2, completing the square. Recall that the inverse operation of squaring a variable or a term is to take the square root. Of both sides of the equation. So let's say I wanted to solve this equation here. I might divide both sides by 3. Right? And then I want to solve for x, so I might take the square root of both sides. And this will be the principal square root. No, the square root. So I would get that either x is 3 or x is negative 3. Okay, not too bad. Let's see over here. If I subtract, I want to solve this, so I might subtract 1 from both sides, and I get x minus 2 squared is 81. Now I take the square root of both sides, and I get x minus 2 is 9, or x minus 2 is negative 9. So here I'm going to add 2 to both sides and get 11 over here, or negative 7 over here. Alright, so the opposite of squaring a term is to take the square root. However, let's think about this one right here. If we have this equation that we're attempting to solve, now here this is different because I have both an x squared term and an x term. Okay, so when I subtract 9 from both sides, I get x squared plus 6x equals, let's see, what's this, 7? But you see, I can't just simply take the square root of both sides because I have both this x squared term and this x term. So if I move this over here, then I have a square root of x term on that side, or a square root of x term on this side. So what we have to do is called complete the square. I want to change this to some single term that's squared. Alright, so I want to review very quickly a concept you might not have seen in a while. So let's say I want to expand, so this is just kind of a sideline to motivate this process that we're going to do. If I have x plus 4 quantity squared, that's the same as x plus 4 times x plus 4. Okay, then we might expand this out using the distributive property twice, right? This goes to this term, this goes to this term, this one, or in algebra you might have learned an acronym, maybe FOIL, to help you keep all those terms straight. But we get an x squared term, a 4x term, a 4x term, and then 16. So we get x squared plus 8x plus 16. Alright, let's try that again. So if I have x minus 3, we get x squared minus 3x plus 9. So we get x squared minus 6x plus 9. Alright, over here, x minus 5 times x minus 5. I get x squared minus 5x plus 25, x squared minus 10x plus 25. Alright, now what we want to do here is see if we can make any generalizations or see any shortcuts here. So notice when I had a plus 4 term, this piece ended up being an 8, and this is 16. When I had a minus 3, I ended up with a minus 6 and a 9. Okay, a minus 5, I ended up with minus 10 and a 25. Now hopefully you see that this constant term is always whatever this was squared, right? From 4 to 16, negative 3 to 9, negative 5 to 25, right? Because we always have that last term. Okay, so this is always what we started with squared. Now, do you see we had both an inside term and an outside term? So this is always twice what we started with. So if this was negative 3, we end up with negative 6, negative 5, negative 10. Okay, so we're going to use this fact in just a second. But let's say I had x plus, I'm just going to call this c maybe, quantity squared. Okay, our shortcut, instead of doing all this distributive property, we might say x squared plus, well this is always twice whatever I started with right here. So this would be 2c times my x, and then my last term we took whatever this was and squared it, plus c squared. So if you remember that property, it's going to help us as we complete the square. So here's what we want to do. I realize these instructions are very abstract, but that's okay. We're going to come back to them after we see an example, but this can get complicated when I have A's, B's, C's, D's, and F's as opposed to numbers. But the first thing we're going to do is we're going to start off like we did before, and we're going to subtract this constant to the other side of the equal sign, okay, as we did before. So the first thing we're going to do is add or subtract any constant terms to the other side. Now, the second thing we're going to do is, if there is a constant, or a coefficient, excuse me, in front of this x squared term, we're going to divide every term by that, just to make our arithmetic a little simpler. Alright, the third thing we're going to do, now I want to complete the square. I want to change this stuff right here on the left hand side of the equal sign to some quantity squared. Well, to do that, we're going to use that property we just saw, where we take the coefficient of x and cut it in half, because remember that was always doubled, and then we're going to square that. But if I add it to one side, I have to add it to the other to keep everything balanced. Then this piece right here, we can factor, or we can make this into a perfect square. Now, once I get to this step, I can then take the square root of both sides as we were wanting to do before. Now, I realize those slides I just showed you are very, very, very abstract. So let's go through an example and then we're going to come back to that. Okay, so let's say I wanted to solve this. The first thing I might do, step 1, I want to move this over here out of my way. Okay, so I end up with x squared plus 2x. I am going to leave a little bit of room there. The opposite of subtracting 7 is to add 7, so I end up with an 8 over here. Alright, then step 2 excuse me, was if there was a coefficient of x squared, I need to divide every term by that. Well, there isn't one, right? So check, we're done with step 2. Alright, now step 3. If this was a perfect square, what would I need right here? Well, remember, to figure out what I need right here, I look at this term and I'm going to cut that in half. So 2 divided in half is 1, and then I'm going to square that. Alright, so 1 squared is 1. So I wish I had a plus 1 right here. Well, if I add 1 to the left-hand side, I have to add 1 to the right-hand side. Okay, so I take this coefficient of x, cut it in half, and then square that number, and that tells me what I need right here. Alright, now, this is nice, because now this is a perfect square. So this is going to be x plus 1 quantity squared is 9. Now, let's make sure everyone understands how we got here. Alright, so we're going to cut this term in half, right? So we divide it by 2 always, because we had the inside term and outside term, and that tells me what goes here. Alright, and then we take this value here and we square it, and that tells me what I wish I had there. Now to factor this, this is x plus 1 times x plus 1, or x plus 1 quantity squared. Now we are ready to solve this. Okay, I'm going to take the square root of both sides of my equation. So if I take the square root of x plus 1 quantity squared and the square root of 9, well, the square root of this is just going to be x plus 1. Square root and squaring something are inverse operations. Now, here, this could either be positive 3 or negative 3. So it could be the case where it's 3, or it could be the case where it is negative 3. So then I add 1 to both sides. Either we get a solution of 4, or we get a solution of negative 2. Alright, let's look at another example here. Alright, so the first thing I want to do is take this constant term over here and subtract it to the other side. So if I subtract 32 from both sides, I have 2x squared minus 16x. We're going to subtract that over. I'm going to leave a little room there. And so then I would have 18 on the right hand side. Now, step 2, remember we said if there was a coefficient of x squared, just to make our arithmetic a little simpler, we're going to divide every term by that coefficient to get rid of it. So here I'm going to have x squared minus 8x, and then on this side now I'm going to have 9. because I divided every single term by 2. Alright, next. Alright, what do I wish I had right here such that this was a perfect square? Well, I'm going to look at -8 and cut it in half and get -4. Okay, then I take that -4 and I square it and I get 16. So I wish I had 16 right here. Well, if I add 16 to the left hand side, I also have to add 16 to the right hand side. Alright, so I have 25 over here, and now this stuff is a perfect square. Okay, I'm going to have x minus 4 quantity squared is 25. Now let's just quickly review how we got this. We took this value, -8, the coefficient of x, and cut it in half. Right? We divide by 2 to get -4. Then we took this -4 and squared it to get positive 16. Alright, now we have a perfect square here on the left hand side. So now what we can do is just like we were starting at the beginning, I can take the square root of both sides of my equation. So we're going to have x minus 4 quantity squared, take the square root of that, and 25, we're going to take the square root of that. So then from here, I get that either x minus 4 is 5, or I might get that x minus 4 is -5. So then my solutions, if I add 4 to both sides, are either x is 9 or x is -1. So that is our process of completing the square. So let's look at that example that we started with just a second ago that we could not solve a minute ago because it had irrational solutions. So I think we said that the shorter side we were calling W, and then the other side, the length is 4 more than W. Okay, and when we multiply those two, we get an area of 101. So if I take W times W plus 4 equals 101. Alright, now I'm going to distribute as we did before, and I get W squared plus 4W equals 101. Now, a second ago we tried to subtract 101 over and factor, and we saw it didn't work. Well, we have already, in the form we have now, we have already completed step 1, right? There's no constant on the left hand side. And we have already completed step 2. There is no coefficient of W. So now we can jump all the way to 3. Now what do I wish I had right here? Well, I think I would like, if I cut this in half, that would be 2, square it, and that would be 4. So I wish I had a plus 4 here. That would make that factorable. Alright, well, if I add 4 on this, the left hand side, I also have to add 4 on the right hand side. So now I have a perfect square of x plus 2 on the left, and then I have 105 on the right. So now this we can solve by taking the square root of both sides. So then we get x plus 2 is equal to, now I don't know the square root of 105 in my head. We could use the calculator, but remember the calculator is only going to give us the principal square root. So if I do the square root of 105, we get 10.247. But we have to remember there is also a negative root. Negative 10.247. Alright, and then we subtract 2 from both sides and we get that x is 8.247, or x is negative 12.247. Alright, now let's see here. If I am thinking about the width of a shorter side, does everyone see that a negative value is not going to make sense here? Alright, so we end up with this solution of 8.247 yards. Alright, so that is our second strategy, completing the square. Let's see if we can try another one here. Alright, so we have a 9 by 11 piece of art here with a frame of unknown width. So let's see, this is 9 and this is 11. Okay, then we have a frame of unknown width. Well, we're going to use X to represent the width of this frame, which we are trying to figure out. So then okay, now the area of the framed piece of art, so all of this is going to be 255 square inches. So all of this, including my picture and my frame, is 255 square inches. Now we need to figure out how wide this frame is here. Alright, so this is going to be area, so we're going to do this area here, or this, we'll call it width here. Well, if I had 9 for my art and I added X over here and I added X over here, this is going to be 9 plus 2 X's. One up here and one down here. Okay, if this piece was originally 11 and then I added a border of X on the left and X on the right, that's going to be 11 plus 2X. So then to get the area, we are going to multiply these two. So I'm going to have 9 plus 2X times 11 plus 2X gives me 255 square inches. Okay, now the first thing we need to do is use our distributive property, or you might have memorized the acronym FOIL, to expand all this, and then we're going to subtract, well, no we're not, and then complete our square. Okay, so here I'm going to get 9 times 11 is 99. Alright, 2x times 11 is 22x. Okay, then 9 times 2x is 18x. And then 2x times 2x is 4x squared equals 255. Alright, and I am going to combine some of these terms. Let's see, 4x squared plus, this would be 40x, I believe. And then 255 minus 99 gives me 156. Alright, next thing we want to do, I don't like this 4 in front of the x squared term, so I'm going to divide every single term by 4. So I get x squared plus 10x 156 divided by 4 gives me 39 over here. Okay, now what do I wish I had right here such that this was a perfect square? Well, I take 10, cut it in half and get 5, and then square that. I wish I had a 25 right here. So I'm going to add 25 to both sides. So then this side now is a perfect square. X plus 5. Alright, and again, how did we get there? We take this term, cut it in half. Alright, and then we take this and we squared it to see what I needed there. Well, if I add it on the left, I have to also add it on the right. Okay, so now the right hand side, if we add 25 to that, is 64. Okay, now that we have a perfect square on the left, we can take the square root of both sides. I'm going to take the square root over here, square root over here. So we're going to get that x plus 5 is square root of 64 is 8, or x plus 5 is negative 8. Okay, now we are going to add 5 to both sides. So we're going to subtract 5 from both sides, and I get a value here of 3. And then over here, if I subtract 5, I get negative 13, I believe. Alright, now if I'm thinking about the border of this, obviously negative 13 doesn't make sense. So we're going to get that the border here is 3 inches. Alright, and that's how we might solve this, by completing the square. Okay, our third strategy then is to memorize this quadratic formula. So this is the same result as we had with completing the square, only instead of memorizing or learning a process, we just memorize the result. So if we get our equation in the form something equals 0, then we're going to have two solutions. We're going to have one which is negative b plus the square root of b squared minus 4ac all over 2a. And we're going to have a second solution that is negative b minus the square root of b squared minus 4ac all over 2a. Now, if you wanted, we could complete the square for this using a's, b's, and c's, and we would end up at this result. What's nice about using this strategy is I can look at this stuff under the radical here, this b squared minus 4ac, which is called the discriminant, to see which of those three cases we started with we fall in. So just to quickly jump back, we could have no solution, we could have one solution, or we could have two solutions. So if my discriminant is negative, if I take the b, square it, minus 4ac, and I get a negative value, well, we can't take the square root of a negative value, or we get a complex solution, something that's not real. So here we're going to say that there is no solution if that is negative. So that was the case on the far left that we just saw over here, where there's no solution. Here's my right hand side. my left-hand side of the equation, my right-hand side of the equation, those are never the same. This value is positive, where we're going to have one positive root and one negative root. So this would be when we have two solutions over here where we intersect in two different spots. Okay, now the third case you've probably already figured out then is if this is exactly 0. So b squared minus 4ac is exactly 0. Well, then this piece right here goes away, right? Well, if that's the case, then I'm just left with negative b over 2a, in which I only have one solution. And that was the case in the middle, where just the tip of my parabola touched that constant. The advantage of this strategy is it's pretty quick. The disadvantage is you're going to have to memorize that formula. That will not be given to you. So let's say we have a right triangle where one leg is 7 centimeters longer than the shorter leg. Alright, so we're going to call this, I don't know, x. Then the other leg is 7 larger. And then the hypotenuse is 8 centimeters larger. We want to find the length of all three sides. Now, you're going to have to remember back to geometry. If you have a right triangle, do you remember something like a squared plus b squared equals c squared, Pythagorean formula? So I'm going to take my shorter leg squared, x squared, plus my other leg squared, x plus 7 quantity squared, is going to equal x plus 8 quantity squared. In order to use the quadratic formula, I need to get everything on one side equal to 0 and then combine all my terms. So here I have an x squared. Okay, when I expand this, I get x squared plus 14x plus 49, and I'm using that shortcut we just saw a minute ago, equals, now I'm going to expand this, again using my shortcut, I get x squared plus 2 times 8 would be 16x plus 8 squared is 64. Okay, now I want to get 0, let's say 0 on the right hand side. So I have an x squared term here, x squared term here, those are going to cancel. Now I want to get rid of this 16x, so I'm going to subtract 16x right here. And then I want to get rid of this 64, so I'm going to subtract 64 from this constant term. Alright, so we get x squared minus 2x minus 15 equals 0. Okay, now for you guys that were quite efficient at factoring, you could likely factor this quicker than I could do the quadratic formula if it factors. But we are going to try to use the quadratic formula here. So our a coefficient, well, there's nothing in front of x squared, so I'm going to say a is 1. My b coefficient is -2, and my c coefficient is -15. So if we use our quadratic formula, we're going to say that my values here, we're going to have two. One negative b plus the square root, and one negative b minus the square root. Alright, so negative 2 is positive 2. And then we're going to have one plus and one minus. The square root of, okay, b squared, so that would be -2 in parentheses squared minus 4 times a, well, a is 1, times c, which is -15, all over 2 times a, which is 1. Now, what is important here? When we put this into our calculator, I need parentheses around my numerator. I'm going to need parentheses at the beginning and end of my radical. And the other set of parentheses that students sometimes miss is that we need parentheses here. Okay, because it's -2 times -2, which would be +4, not -2 squared, which would give me -4. Alright, so let's see if we can punch that in our calculators correctly. Alright, so I'm going to open the parentheses for my numerator. 2. I'm going to start with the plus. Square root, open the parentheses for my radical. Now here I want -2 squared in parentheses minus 4 times 1 times -15. Close the parentheses for my radical. Close the parentheses for my numerator, divided by 2 times 1. Alright, and I get a value of 5. Okay, now, so we're going to get from here, we get one result of 5, but we can't forget about the 2 minus that radical. So I'm going to, again, open the parentheses for my numerator, 2 minus, square root, open the parentheses for my radical, then open the parentheses again for my -2, quantity squared, minus 4 times 1 times -15, close the parentheses for my radical, close the parentheses for my numerator, divided by 2 times 1, which is just 2. And we get -3. Okay, so if I'm thinking about the length of a side, this -3 solution I'm going to throw out. Okay, so if this side is 5, right, we just found that x is 5, this side is going to be 7 more than 5, which would be 12, and then this side would be 8 more than 5, which is 13. So that's our quadratic formula. Alright, so you have 37 feet of fencing to enclose a rectangular garden. So if I go around all 4 sides here, 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 and here, that's going to be 37 feet. Okay, this garden has an area of 85 square feet. We want to know, what are the dimensions of the garden? Well, we're going to call this one width. Well, now, I want to put this side in terms of W. So I know that these two are the same and the widths are the same. Well, if I have 37 to go around all 4 sides, let's say I only go around 2 sides. Let's say I only consider these 2 sides, because the other 2 sides are the same. So if I had 37 feet to go around all 4, do you see I would use half of that fencing to just cover the width and the length? So I would have 18.5 to cover what I have in blue here. Okay, so if I've used W here, this would be 18.5 minus W. Alright, so that was the tough part. Now, once we've figured out how to get that length in terms of W, we have length times width equals area. So W times 18.5 minus W gives us 85. Okay, I'm going to distribute my W, so I get and subtract the 85 over to get 0. Alright, so in this case, my A term is -1, my B term is 18.5, and my C coefficient or constant is -85. Now we can use our quadratic formula to see if we can solve this. So negative B, -18.5, plus or minus the square root of B squared 18.5 squared minus 4 times A times C, all divided by 2 times A. Okay, and this time let's put parentheses around our numerator. Maybe also put parentheses around our denominator, the beginning of the radical and the end of the radical. Alright, let's see if we can type that into our calculator correctly. Negative 18.5, we'll do the plus first, plus the square root of, open the parentheses for our radical, 18.5 squared minus 4 times -1 times -85, closing for our radical, closing for our numerator, divided by 2 times -1, and I get 8.5. Okay, let's do the same thing for our second root. So I'm going to open the parentheses for my numerator, negative 18.5 minus this time the square root, open the parentheses to begin our radical, 18.5 minus 4 times -1 times -85, close them for our radical, close them for our numerator, divided by, open them for our denominator, 2 times -1, close them there. Oops, and I have done something incorrectly. Let's see here. Negative 18.5 minus the square. Oh, I never squared my 18.5. Alright, that looks a little better. So we get 18.5 and we get 10. Alright, so this time we get one value that is 8.5 and another value which is 10. Now in the last couple examples we've seen, we've thrown away one of ours. Well, this time either of these would work, right? They're both positive, so if this width is 8.5, this is 10. If this width is 10, the length is 8.5. So what are the dimensions? The dimensions here are 8.5 inches, nope, feet. 8.5 feet by 10 feet. Alright, we're now at number 4. Our fourth strategy for solving quadratics is to do them exactly as we did in section 1.1, where we talked on page 9, where we talked about the difference between solving as compared to evaluating. Okay, So we can solve this either using our graph menu and finding the intersection, right? And to do this strategy in y1, we might put the right hand side of the equation, and then in y2 we're going to put the left hand side of the equation. And then to find out where those equal, we find the intersection. The only tough part about this strategy is finding a window in which we can see the intersection, because if it's not in our window, the calculator won't find it. Okay? Or we can use the equation menu and use the solver. Alright, so the advantage of the solver is we don't have to worry about the window, but the disadvantage is the solver stops when it finds the first solution. So if there are two solutions, we might not know that from the solver necessarily, where the graph menu makes that more obvious. So let's look at an example here. Suppose you have a square piece of cardboard from which you remove a 3" by 3" square from each corner. So let's see. This is 3, 3, 3, 3. So I'm going to cut a 3 by 3 square from the corner and fold this box up. So if I fold these sides up, we end up with a box that has a volume of 48 cubic inches. Okay, so this might be my width, this might be my length, and then my height here is 3. What is the width of this such that we have this volume of 48 cubic inches? Alright, the first thing I know is if this is a square that I started with, this is going to be the same as, the width is the same as the length. Okay, so this piece right here, if I started with x and I subtracted 3 from each side, this is going to be x minus 6, as well as this is x minus 6. Okay, so if I think of volume, length times width times height is going to be 48. Okay, well here my length is x minus 6. My height, or no, my width is also x minus 6. And then my height, if I fold this up, that's going to be 3. Alright, now the advantage of using the calculator here is I don't need to worry about all this expanding and algebra stuff. I can put this just as it is. Let's use the graphical approach first, right? So maybe this is my right hand side of the equation, and then this is the left hand side. Alright, so let's see here. I'm going to go to my graph menu. Alright, and enter my right hand side in y1. Let's see here, x minus 6 times x minus 6 times 3, and then we get a left hand side is 48. Now we need to pick a window here. Well, I know my solution needs to be positive. So if we're multiplying something, let's maybe look, I don't know, I'm just going to guess 0 to 10 to start with. I'm going to draw this and do a shift, zoom, auto. Alright, now I can clearly see one solution here. Now it looks like I might be missing this one over here on the right, so I'm going to change my viewing window a little bit. Let's go to 12. Draw, and then try a Shift Zoom Auto. Alright, now that I can see both solutions, to get the calculator to find them, I'm going to go to my Graph Solve menu, Shift G-Solve, and I want the intersection. Now the first intersection is 2. The second intersection is 10. So we get that x algebraically could be 2 or 10. Now let's come back to the context. If this side was 2, 2 inches, would it be possible for me to cut 3 inches and 3 inches, or 6 inches off? Well, no, that one's not going to work. It's too small. Now if this was 10, then I could cut 3 off and 3 off, and I would still have 4 left here, 4 left here, and then 3 there. So my answer would then be 10 inches. Okay, now let's try to do this with the solver. If I go to my equation menu, alright, I'm going to go to the solver, and I'm going to enter my equation. So we had x minus 6 times x minus 6 times 3. To get our equal sign, we're going to hit Shift and then the decimal, 48. Now we need to give it an initial guess. Let's give it an initial guess of 5, let's say, and then solve. Okay, and this gives us our first solution of 2, which we saw before. Now, what might not be obvious when you're using the solver is that there is a second solution. See, it was pretty obvious when we saw the graph. We saw 2 intersections. So I'm going to have to change this initial guess. First I guessed 5 and I ended up with a solution of 2. So maybe this time I guess 20. And solve, and I get the second solution. So one drawback of the solver is that if there's more than one solution, it might not be obvious, and there's a lot of guessing going on here as to which initial guess gives you the solution that you need. Alright, last example here. Currently we have a 10-foot by 12-foot work shed. Well, what we want to do is I want to push both of these walls back by some amount x, such that I double the amount of work I had. So before, initially I had 10 by 20, which would give me an area of 10 times 12 would give me 120 square feet here, right? Well, we want to double that. I want my new area here, after I've moved my walls, to be twice that, which would be 2 times 120, which would be 240. Alright, so my new width is 10 plus x. My new length is 12 plus x, and I want that product to be 240. So I have 10 plus x quantity times 12 plus x quantity equals 240. Alright, now if I'm using my technology here, I don't need to do any simplification. Let's go to our graph menu. I'm going to put 10 plus x quantity times 12 plus x quantity equals 240. Now I need to pick a window. Alright, I know I want this to be positive. We had 0 to 12 before. Sure, that'll work. Let's try that. Or it might not work, but we'll find out. Shift, zoom, auto, and I do see an intersection. Now, if this is my parabola, can you see there's going to be another intersection over here that would be negative? We can change our window just so we can see it, but do you understand we're going to end up throwing that one out anyway? Shift, zoom, auto. Okay, there's my positive one. I need to go even more negative. Let's go negative 20. Still don't see it, do I? Alright, let's go even further. Shift, viewing window, let's go negative 30. There we go. Now that I can see both solutions, we'll find both. But this negative solution, I already know I'm going to throw it out because we're talking about a length. So I'm going to go to my Graph Solve menu, Shift F6, then intersection. The negative value is negative 26. And then the positive value here is 4.524. Alright, so we might get two solutions, but we're going to throw one of them out, right? Negative 26.524. And x equals, to jump to that positive solution, we're going to use the right arrow and we get 4.524. Alright, and then we can throw away this one. Okay, so if we use our solver, hopefully we will arrive at the same result. I'm going to go to my equation menu, go to the solver, I'm going to enter my equation, 10 plus x times 12 plus x equals, shift and the decimal for my equal sign. I'm doubling that area, so that would be 240. And let's give it an initial guess of 10 maybe, solve, and we get the positive value. Okay, you could continue, you'd probably have to give it a very negative guess. That's negative 50 to get the one that we're going to throw away, but or just stop at the one that makes sense. We get negative 26.524. Alright, so we're going to move this back by 4.524, and my units here are feet.